Ahoy! That's Chuck for hello. Today we're talking about quadratic functions and equations. So first, jot this down. There should be a link to the notes, or you can write as you go. Okay, first remember that f of x is the same as y. So if you want to write y, that's fine. Same thing. If you have that set equal to ax squared plus bx plus c, we call that a quadratic function. So remember, quadratic function means that the term with the highest degree, which would be this one, has a degree of 2. All right, if we set that y equal to 0, so we're just changing the f of x or the y to 0, we call that a quadratic equation. And please notice both ways, whether you're talking about the quadratic function or quadratic equation, notice they're in standard form. So both are standard form. This is where you go, oh gee, Miss Stratman, I completely forgot what standard form is. That's okay, a little reminder. Standard form, that's when you go from greatest degree to smallest degree. So for example, this term has a degree 2. This term has a degree 1, because remember, if there's no exponent, there's a 1 hiding there. And then your constants, if you just have a number with no variable, that's degree 0. And something I really want to point out, because it's super, super important, if you're talking about quadratic function or quadratic equation, and that coefficient, remember the number in front of a variable is called a coefficient, that coefficient in front of x cannot be 0. So I would write that down. A does not equal 0. This is so important. A does not equal 0. A does not equal 0. Please, please, please. If A equals 0, we do not have a quadratic function. We do not have a quadratic equation. All right, moving forward. You can also have, instead of standard form, we also have vertex form, and here's what it looks like. Y equals A. Then we're going to have x minus h, quantity squared, plus k. Now, it's good to know that's called vertex form, but we really, really like standard form. So we're going to really focus on standard form. So let's practice getting equations into standard form. All right, our first one, we have 5x plus 3x squared minus 9. Oh, somebody just tweeted me. All right, we need to put it in standard form. So ask yourself, what is standard form? Standard form is when we go from greatest degree to smallest degree. So that means our first term should be 3x squared. That's the greatest degree. Our second term should be this one. Hey, is this positive or negative? Well, remember, if there's no negative sign in front of it, then we assume that that's positive. So it's plus 5x. Then we have minus 9. It still equals 0. So sometimes if you're lucky, you just have to do what we just did, which is you just have to rearrange. Okay, number 2 is a little more complicated. Notice it's not equal to 0. So we need to get everything on one side. Well, I'm going to move everything over to the right side. We've done this before. So first, to move this 4x, I'm going to subtract 4x from both sides. And when I say from both sides, remember, I always mean from both sides of the equal sign. All right, so nothing happened to this negative 7. Uh-oh, negative x. Remember, if you have no coefficient, there's a 1 hiding there. So negative 1 minus 4, that's negative 5. And don't forget your x. All right, we're almost done. We almost have it with 0, so equals 0. We have a minus 7 over here. So to make that 0, we need to add 7 to both sides of the equal sign. And I'm running out of room. I made a mistake. I didn't count my lines. All right, so now negative 7 plus 7, that's 0. Nothing happened to 6x squared. Nothing happened to the negative 5x. And then 9 plus 7, that's just 16. So what we did here is we moved by adding or subtracting. There's one final way. Hey, we've seen this before. This is called vertex form. We want it in standard form, so the first thing we got to deal with is this exponent right here. So we're going to make our box. Yay! We love that box. We got really good with that in Unit 2 or Unit 6. All right, so let's make a box so we can figure out what x plus 4 quantity squared is. So here's my box. We got x plus 4 times x plus 4. Well, x times x, you can just add your exponents. Remember, no exponent, that's okay. There's a 1 hiding there. So we have x to the 1 plus 1 is 2. 4 times x is 4x. 4 times x, again, 4x. And 4 times 4, that's 16. So here's our whole box, x squared plus 4x plus 4x plus 16. Well, we need to combine some like terms. Those look like terms. So we get x squared plus 8x plus 16. But be careful, don't stop there. Don't think, oh, we're done. That was just this part of the equation. So we're going to take this and plug it back in, woo, for what we had here. So 0 equals. But instead of x plus 4 quantity squared, we just found out that is this sucker right here. So x squared plus 8x plus 16. And then don't forget, we had this minus 5 hanging out. So one more time, combine your like terms. And finally, we get 0 equals x squared plus 8x. 16 minus 5, that's a positive 9. There we go. That is standard form. Let's move on to the next page. All right, so we've got quadratic functions, we've got quadratic equations. Now we need to use this lovely thing called the quadratic formula. Good news. Today, we're just going to use a tiny part of it. Tomorrow, we'll use a bigger part of it. So remember, standard form. Before you can use quadratic formula, you have to be in standard form. Really important, you have to be in standard form. And reminder, a cannot equal 0. So important. I'll repeat it because it's so important. A does not equal 0. Okay, here's the quadratic formula. And good news, it's on our EOC reference paper. If you look, where is it? Where is it? Way down at the bottom. So at the very bottom of the page, quadratic formula. We're just writing out this. So if you're in the classroom, you've got access to this. If you're not in the classroom, you have access to it on your Chromebook. So here it is, x equals, and now I'm going to embarrass myself. My teacher, we had to memorize it, so they taught me a song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So right now, be thankful that you don't have to sing that song. Okay, we're going to ignore most of this formula. We're just going to focus on this part. That b squared minus 4ac, we're calling that the discriminant. If you plug in your numbers, b squared minus 4ac, and you get a number bigger than 0, we're going to say that that has 2 real solutions. We'll talk later about how could it not be real. Okay, if b squared minus 4ac, the discriminant, is equal to 0, you're going to have 1 real solution. And if your discriminant is less than 0, there will be no real solutions. We're going to do some examples. So we're going to find the number of real solutions using the discriminant. And then your notes might say this. We're not going to find the solution set. Not yet. Okay, so step 1. I'm going to write my steps over here. Ask yourself, is it in standard form? Yeah, it's in standard form. We have the highest degree down to the lowest, and it's all equal to 0. Okay, so next question, ask yourself what A equals. What does B equal? What does C equal? So I'm going to write that A. A is the coefficient for x squared, so it's 2. B is your coefficient in front of x, so our b is 3. And c is your constant, so negative 5. Awesome. Step 3, look at your discriminant. So here it is, b squared minus 4ac. Use parentheses. So we're going to have b squared, so 3 squared, minus 4 times a, which we said is 2, times c, which we said is negative 5. Okay, let's do some solving. Reminder, this is the discriminant. Okay, 3 squared is 9, minus 4 times 2 is 8, and I'm just bringing down that negative 5. Okay, negative 8 times negative 5 is positive 40. 9 plus 40, well, that's 49. And I hope we're not asleep. We all know that 49 is greater than 0. So if we look back up our page, our discriminant is greater than 0, so we have 2 real solutions. Let's go on to the next one. Okay, so step 1, is this in standard form? Ah, heck no. It's got to be equal to 0. So to get this equal to 0, I need to move this term over. To move this term over, I'm going to subtract 2x from both sides of the equal sign. So 2x minus 2x, that's 0. Remember, I want to end up in standard form, so start with the highest degree, x squared. Then the only x we got is that minus 2x. And then bring down your minus 3. So remember, only combine like terms. Nothing else has just an x, so that negative 2x doesn't combine with anything. Okay, now we're in standard form. Now we're rocking and rolling. So we got to figure out what a, b, and c are. Uh-oh, there's no number in front of x squared. What's a? Oh, silly Stratman. There's a 1 hiding there, so a is 1. B is our coefficient in front of x, which is negative 2, and c is negative 3. Okay, now we can look at our discriminant. So remember, discriminant is b squared minus 4ac. So b squared is negative 2 quantity squared minus 4 times a, which is 1, times c, which is negative 3. All right, so that equals negative 2 squared, that's 4, minus 4 times positive 1, that's minus 4, and then bring down your negative 3. All right, we're going to bring down this 4. Negative 4 times negative 3, that's positive 12. Well, 4 plus 12, hope you all know that, 16. Now ask yourself, is 16 greater than, equal to, or less than 0? Well, obviously it's greater than 0. If we look back at that previous page, if you have your discriminant greater than 0, 2 real solutions. One more example, then I promise we're over. So ask yourself, is this in standard form? Yeah, sure it is. We got x squared, we got x, and 10. All right, in that case, we need to find a, b, and c. Since there are no coefficients, remember, there's really 1s hiding there. So a is 1, b is negative 1, and c is 10. Okay, let's check out our discriminant. Once again, discriminant is b squared minus 4ac. So we take our b, square it, minus 4. Don't forget your a. Don't forget your c. I bet you know what to do next, other than stutter. Negative 1 squared, that's positive 1. Negative 4 times positive 1, that's negative 4. And don't forget about that 10. All right, we end up with 1 minus 4 times 10 is 40, which is negative 39. So how many solutions do you think we have? Well, since negative 39 is less than 0, There are no real solutions. Awesome. Thank you for sticking it out for so long. You got some practice to do, so get to it. I promise if you do today's practice, tomorrow it'll make tomorrow so much easier. Let me know if you have questions.